Chapter 14 of the devita PARP inhibitors, that is polyadipiribose polymerase inhibitor for tumors with defect in the DNA repair. Introduction. Some cancer harbor defect in the DNA repair pathways leading to genomic instability, and this may not only foster tumorigenesis but can also provide weakness that can be exploited therapeutically. Tumors with compromised ability to repair double-stranded DNA breaks by homologous recombination, including those with defects in the BRCA1 and BRCA2 genes, highly sensitive to blockage of the repair of DNA single-strand breaks via inhibition of the enzyme polyadipiribose polymerase. And this provides a basis for synthetic lethal approach to cancer therapy. And 4 different PARP inhibitors, olaparib, rucaparib, niraparib, and talazoparib, have now received regulatory approval in the United States for the treatment of ovarian cancer, breast cancer, prostate cancer, pancreatic cancer with BRCA1-2 mutation, and in some cases other defects in the DNA repair by homologous recombination. Now, cellular DNA pathway. Cellular DNA repair pathway. So DNA is continuously damaged by environmental exposure, endogenous activities, DNA replication, cellular free radical generation, which causes diverse lesions including base modification, double strand breaks, single strand breaks, and intra-strand, inter-strand cross links. And these aberrations are repaired by distinct repair pathways which are coordinated with the maintain the stability and integrity of the genome. And this faithful repair of DNA damage is an essential prerequisite for the maintenance of genomic integrity and cellular and organismal viability. And when one DNA strand is affected and the intact complementary strand is available as a template, the base excision repair, nucleotide excision repair, or mismatch repair pathways are used, and these pathways are highly efficient at repairing damage and double-stranded breaks, which are more problematic than single-strand break because complementary strand is not available as a template, repaired by the homologous recombination or non-homologous and joining pathways. Endogenous base damage, including single-strand breaks, they are the most common DNA aberrations, and has been estimated that the average cell may contain 10,000 such lesions every day. And base excision repair is an important pathway for the repair of single-strand breaks and involves sensing of the lesion followed by the recruitment of the number of other proteins, and PARP is a critical component in the base excision repair pathway. So PARP is an enzyme discovered almost 60 years ago and that produces large branch chain polyadipiribose PAR from NAD+, and in humans there are 17 members of the PARP gene family, but most of these are poorly characterized, and the abundant nuclear protein PARP1 senses and binds to DNA nicks and breaks, and resulting in activation of catalytic activity causing polyadipiribosylation of PARP1 itself as well as other acceptor proteins including histone. The modification may signal the recruitment of other components of DNA repair pathway as well as modify their activity, and in addition to the base excision repair pathway, PARP enzymes have been implicated in the numerous cellular pathway. The two double strand break repair pathway available within the eukaryotic cell line, non-homologous and joinase and homologous recombination. So homologous recombination can be further subdivided into gene conversion and single strand annealing subpathways, and both this gene conversion and single strand annealing on sequence homology for repair, whereas non-homologous end join uses no or little homology, and non-homologous end joining That is the most important pathway for repair of double strand breaks during G0, G1, and earliest phase of cell cycle. It is likely active through the cell cycle, and this form of double strand break repair usually results in change in DNA sequences that at break site and occasionally in the joining of previously unlinked DNA molecules, potentially resulting in cross chromosomal rearrangements such as translocations. Gene conversion uses a homologous sequence, preferably the sister chromatid, as template to resynthesize the DNA surrounding the double strand break, and therefore generally results in accurate repair of the break. And repair of this gene conversion is critically depend on the recombinase function of RAD51 and is facilitated by a number of other proteins. And the single strand annealing is also involves the use of homologous sequences for the repair of double strand breaks, but unlike GC gene conversion, the single strand annealing is RAD51 independent and involves annealing of DNA strands formed after resection of the double strand breaks. But the detail is not completely understood. It frequently results in loss of one of the homologous sequence and deletion of the intervening sequence. And this single strand annealing is a potentially important pathway for mutagenesis because a significant fraction of mammalian genomes consist of repetitive elements, and this gene conversion and single strand annealing, they are cell cycle regulated and most active in the S and G2 phase of cell cycle. Thank you.